Okay. So, um, how many of you guys got to do the rest of the lessons from that fusion preparation?
I didn't actually do any lessons. I was just kind of winging it.
I watched them, but yeah, there's still a lot that needs to be learned.
Oh, totally. Yeah, that's okay. The goal was just to kind of orient you, kind of bring to mind the toolpaths that exist.
Yeah, I was able to do basically an OptiRough or whatever it is, 2D adaptive,
Cool.
and then I did a 2D contour.
Nice.
Yeah, I
Okay.
was able to do the same thing.
Okay, awesome. So today, since we're now getting into like the practical nuts and bolts of things, I think we're going to end up doing more demo. So I'm going to have parts that we're actively camming together, so you guys can watch and learn. Make sure to ask any questions you got. And other than that, we will fire away. Any questions before we get started on the tool paths that you guys learned about, or anything specific that you have going on? All right, well then, let's fire away. Okay, I'm gonna share my screen. And now you guys can hide. Hey, go away. There we go. All right, and we're gonna come into here. Don't look, this is my secret. Where did I put it? Oh. And boom. Okay, so we'll just briefly go over the most relevant stuff you guys learned. So in the lesson about setup, you guys should have learned how to establish a machining setup. In Fusion 360, they use this saw example here, which was a pretty good example with a bolt down set involved. If we were a professional manufacturing shop, we'd be doing our fixtures in CAM and making all that happen, but we're not. So we're not going to do that. You guys can't.
I'm getting paid to do this, so
I mean,
consider us professionals.
That is true. We just don't run 3,000 of the same piece. We're lucky if we get halfway through a piece before they make changes. Then you guys learned a little bit about roughing. We're actually not going to talk about roughing today, ironically. We're going to kind of take a router-focused approach because that's what Fusion is primarily going to get used for with us. You learned about adaptive toolpaths, which we're going to cover next time. And then 2D finishing, 3D finishing, stock simulation, all sorts of fun, exciting things. Today we're going to dive specifically into setups, 2D contours, and holes. And to demo those, I don't know if any of you have seen this thing that I made a while ago. Basically, I wanted a little board for Scott so he could learn his ABCs. Since then, I've done a better one, but this one's a great one for learning about some of the issues we run into with contours, as well as some problems we run into with other stuff. Okay, so I'm going to walk through a setup real quick. We're just going to ignore the fact that this setup exists, and we're going to make a new one. So when you guys come into do a setup, one thing that's not readily apparent is how it chooses what it initially grabs as your model. Right now, it's grabbed everything in my workspace. That happens every time. Let's say you're in a huge assembly, like my clean CNC assembly over here. It'll grab everything and throw it into that model, as long as it's visible. What you can do is, in your manufacture tab, you can come into this models workspace, and from here you can actually see all of your bodies, all of your components, and you can show and hide those individually. So if you want to save yourself a second or two, you can come in, right click, and you can isolate. And then when you come in here, it'll select the body automatically. Otherwise, you just select the body itself and move on with your life. If you have no body selected, it will warn you about that when you get to camming time. In this case, it won't be a big deal, but it'll warn you. So For now, I'm going to leave it unchecked. That's bad practice. But you guys are going to do something. We'll see that error, and you can know what it is when you get the, what the? Okay, so one of the glorious things about Fusion 360 is it's constantly updating. So this box wasn't here before, and I don't know how to use it. Okay, we're going to manufacture this on a Net A8. Totally kidding. That's a bad idea.
So just, shouldn't you be able to go to your, click on that again? I was just doing this. So just go to your cloud or wherever you have your machine definition stored. Oh, do you not have them?
I don't have machine definitions in mind. I've never used them, but they can be useful. That's what allows you to see like your table. That's what allows you to see a bunch of other stuff in context. I'm sure we can find Haas VF4 and Haas DM1s in there.
Can I share my screen then and just show what that looks like then?
Yep.
How do I do that?
I will.
Where is that?
At the bottom. The
bottom.
Arrow.
Can you do that? Okay, great.
Okay. Oh no, he disabled it.
I disabled it.
He disabled it.
I'm
just gonna keep clicking on it. Maybe it'll change.
I just changed it.
Oh, okay. Share that one.
Oh, I lost screen share.
Okay. Is that looking correct? Can you see? Yeah, so I literally just put these together. I haven't tested them yet, but you can see if you come here, you click on your machine and you've got different, you can put in the dimensions of the machine. So for example, the DM1, we looked it up, it's 20 by 16 by 15.5. You can put in maximum feed rates, maximum tool length, number of tools. So there's a lot of good stuff that you can put in here. And this is also where you put in the post processor.
Wow.
It took like, I don't know, probably good 45 minutes to put all this together, just, looking it up and whatnot. But maybe once we've figured out whether or not it works, we can share these with everybody.
Yeah, that's fantastic, Luke.
Yeah, that's all I had.
Thanks for looking into that. I've never touched that button before, nor have I noticed it before. But what I'm assuming that'll do is later when we post our G code, normally I have to go in and select which machine I'm posting for. I wonder if this skips that step.
Probably, yeah.
Yeah, that's actually really convenient. Luke, if you want to keep looking into that and just kind of share what you learn, and anyone else who wants to look into it too, if Luke has put those machine definitions on the Prototyping Lab cloud, all of you should have access to it through the BYU Prototyping Lab.
I have it in my personal cloud right now.
Oh, okay.
Maybe sometime you and I can get together and you can show me how to put it on the Prototyping Lab cloud.
Yeah, totally. Okay, in that case, I'll share my screen again. Well, we all learned something new. Oh, one other, get over here. One other ADD moment here. Something we learned came in handy. The other day I was modeling a box that I was going to 3D print.
Why? You don't know. Tyler, you should know better.
Oh, I should know better, yeah. But so I'm experimenting with how fast I can push my printer. So a gigantic box is a wonderful thing to test how ungodly fast you can make the thing go. I've gotten it pretty fast, but ignore the ethics of doing this atrocity, and let's move into what I did. So I used some direct modeling techniques to angle this bottom face. It's not angled right now, but I'll show you what I did. So I created an axis about which I could rotate that face through 2 points on there. Then I was able to use those solid modeling tools that move copy feature. I was able to select that face and that axis and rotate that face around the axis. Otherwise, I would have had to come in and do some crazy wonky extrude and set some crazy delimiters in here to make that piece happen, but it worked. Then what I was able to do as well is with that same move copy tool, I was able to translate that face down a little bit to give myself a little bit more wiggle room. This was a part that wasn't really tolerance sensitive, but direct modeling enabled me to do it in 5 to 10, like a minute, whereas I would have had to come in and set up a bunch of weird stuff to get that to happen with extrudes. Anyway, just thought that was a fun note. And then I was able to pattern that around and make cool things happen. Anyway, random note. And then I can close out of that tab. Okay. So we're back to this. So we're creating a setup. We've selected our model. You're selecting your operation type. So the only two we're going to probably end up using is milling and turning. Cutting is what's used for laser cutters or water jets. Supposedly our water jet should be able to work with Fusion 360's cam, which is really nice, but Flow water jet has not been easy to work with, and I have not been able to find a post that would work for it. So we won't do that. Milling is what we'll work with anytime we're on the router or the VMCs. Turning or mill turn is anything on the Romy. Next is your work coordinate system.
Wait,
so
do you have safety glasses? Yes. Why don't you put those on?
Thank you for contributing to the conversation, Luke. I enjoy hearing conversations about safety glasses. I'm just kidding. Okay, so let's talk about work coordinate systems for a minute. So we've got a problem. Let's see. Okay, yeah, I should explain this just to make sure everything works. So we've got a problem. We've got a nice big machine. And I'll just pull up a picture of the VF4 because she's pretty. We've got a really big machine that knows exactly where it is relative to itself. It knows where that tooltip is. Oh, wow, that's a tiny picture. It knows where that tooltip is relative to every other part of itself, which is wonderful. But the problem is we've introduced a little bit of uncertainty. We've gone in and, oh, joy. And inside this wonderful machine that knows exactly where it is, we've stuck some random piece of oddly shaped junk on that table, and we want to tell it to make it into something very, very precise. The issue becomes we have to let the machine know the relative orientation and location of that part. If I'm milling a box thing like this, and I size my stock exactly, but I put it in and it's skiwampus compared to those axes, the machine doesn't like that. There are ways we could specify things like that, but it's atrocious and obnoxious. But what we have to do is we have to be able to tell the machine where this part is and how it's oriented. There's two sides to that, one in hardware and one in software. In hardware, suffice it to say for now, when you all go to CAM later, you'll end up using the probe. So you'll come in with a part probe and it'll come in and it'll tap the different sides of this box. You'll do a bunch of things to set it up. But we can't really work on that right now because we're not there, which is sad. But I'm going to talk to you about the software side. Basically, in our software, we have to specify what point are we going to tell the machine to look at. We're not going to go into all the intricate details of the selection of that. We'll handle that at a later day. But suffice it to say for now, I'm going to tell it things about my stock and things about its position. So we're going to jump over to the stock tab first, just because you can't really specify geometry without knowing what that geometry is. There's a number of options with your stock. You can choose a fixed size box, which means I can come in and say, okay, I have stock that is that's this size. It's 12 inches by 12 inches by 1 inch. I know that's my stock size, so I'm just going to punch that in. Or you can say a relative size box, and you're going to say, I don't know what size my stock is yet, but I want this to figure it out for me. That's what I did here. I modeled the thing, and I needed to figure out how large I need my stock. So I come in, relative size box, and I set all my offsets to 0. So you can see what it does is it creates a box that is just large enough to contain everything I've modeled. Same thing happens if you pick a cylinder. This is the smallest cylinder that can contain all of the material I've done. I can specify the axis of that cylinder and do atrocious, horrible, no good, very bad things like this. Or I can be a good human and I can use square stock. Okay, what I'm gonna do for here is I'm gonna come in and I'm gonna say, okay, that's the size it needs to be, but because of certain things, I'm gonna add an additional ½ inch to every side of this. And top and bottom, I'm not gonna add anything, and we'll call that good. It's 14.5 by 11.25 inches by ½ inch thick piece of stock. That's a good size. I can come up with something like that. Then what I need to do is I need to come in and select which point on this part am I going to tell the machine about. There's a bunch of thinking that goes into this. For now, I'm just going to say on the router, most often we specify top dead center of your plate stock. There's all sorts of considerations in this, but for a piece like this I'm doing on the router, I'll probably specify top dead center. And then I don't select fixturing.
Is that where it goes automatically every time, or is there?
I think so.
Where it'll like put it off in a weird spot.
I mean, regardless, you should check because that's kind of a critical deal. This is the easiest way to completely ruin everything. I tell the program, I'm going to tell you where this point is, but then I probe top dead center, I can break things very fast and very efficiently. Yeah, definitely check that. One of the scary things that happens is sometimes you'll pull it up and you're like, ah, great, looks good, go forward. But you don't realize I've specified bottom dead center of this stock. Bad things can happen if you think about that wrong too. So double check, be very sure before you move forward with anything. Once you've set up the size of the stock and what you're going to tell the machine to locate, then you can move forward. Once again, I can't emphasize the importance of those two things enough. We can't do anything. We can't make any assumptions about machining unless we tell the program size of stock and where it is. Okay, questions up to this point. That is kind of a big thing and it's a little hairy to wrap your brain around. What questions do you guys have? Specifically, Johnny and Benjamin and Corbin, who haven't done CNC work up to this point. What questions you got? Johnny, I think you're muted.
Oh yeah, I was muted. Sorry about that.
You're good.
Yeah, so for the X and the Y, are they always in that direction?
Thank you for bringing that up. That is a very good point. That's another thing you have to specify is the orientation. So okay. I come in, thank you. Orientation, there's a number of options here. Model orientation, like 90% of the time, you're gonna forget to model it in the right orientation, you're gonna need to change it. I've gotten in the habit of doing it this way. But what you can do is you can select a number of things. Any of these options will specify it specifically. Z-axis / plane and X-axis are the ones I tend to use most often. So I'm going to say, okay, this plane is orthogonal to my Z-axis. And I'm going to say this line right here is what I want my X-axis to line up with. You'll notice it was like, oh, okay, yeah, you want your X-axis in that direction. I'm going to put it off to the left. That can screw you up. That's another thing to be very careful of. If I were looking at the machine, this part would be machined this way. For a part that's symmetrical, that's not a big deal. But let's say I'd specified that corner down there. All of a sudden, everything goes to pot. And your machine thinks your stock is over here, when it's actually over here, and you can break stuff really fast.
Okay.
So.
It totally depends on what the positive direction is on the machine, right?
Correct.
And it's always to the right?
Yeah, in general, X is to the right, Y is forward, and
Okay.
Z is up.
Okay, got
That's the general way things work. Where the 000 doesn't matter to you, but those are generally the directions that it works in. And it totally looks like I just flipped you guys off. I'm sorry about that. But that can change if you're a really screwy human being and you bought the wrong machine. So what I need to do is I need to flip this x-axis. I can either click this box or I can just click the arrowhead, and that will flip it as well. There's also a number of selection tools you can do in here. So I clicked a stock box point. That's saying, okay, here's the stock that I'm using. Let me select one of these finite points. I can also come in and just select any arbitrary point, like the bottom left corner of my V, or I can select a model box point, which puts my model in a very tight-fitting box, and then I can come in here and do this. There's all sorts of selection methods there. For now, we'll just deal with stock box point. That's probably the most common one to use, unless on the router at least. Okay, once again, that was a lot of information. Any questions about selecting where your origin is and getting it in line with your part? Okay, great. Okay, so we've got a setup now. All that does, all of that wonderful work, oh, my computer's freezing. All that wonderful work is just to tell the machine two things. How big is my part? And where is it? And what orientation it's in. So I guess that's three. But those are three critical things that you can't make any other assumptions about. Okay, from there, we can start actually coming up with tool paths. Okay, we're gonna talk first about 2D contours. So there are 2D, let's just talk about operations in general. The way we tell the machine how we want it to make things is through toolpaths. These toolpaths come in a couple different flavors. We have 2D flavors, we have 3D flavors, and then there's everything in between. The most common ones you will use are listed up here. Facing, 2D adaptive clearing, 2D contours, 3D adaptive clearing, and then a bunch of finishing techniques. In the 2D world, life's a little easier. You often just do an adaptive clearing and do a 2D contour and face things occasionally. Very rarely will you use others of these tools except these three and that one occasionally on the router. For now, we're gonna focus on contour. So when I come in to select a contour, anytime I click on any operation, I guess, it pops up a box that looks like this. Is that large enough to be visible to you guys, or is it pretty small?
Good.
Okay. Oh, shoot. Oh, man, I just ruined a thing. What? Oh. Hold the phone. Okay, well, whatever. We'll go with this. So these 5 tabs, I can't remember if in the videos, I think it did explain these, but these 5 tabs will pop up on every CAM operation that you do. You're gonna specify your tool. You're gonna specify the geometry you want it to cut. You're gonna specify how high you want your tool at different points in that. You're gonna tell it in the passes tab, things that pertain to when the tool is engaged in the material. And in the linking tab, you're gonna tell it things about when the tool is not engaged in the material. So when it's moving around the material, but not cutting. There are a couple little exceptions to those, but we won't worry about them until later. We'll see them specifically as we get there. Okay, in general, you follow in that order. Tool, geometry, heights, passes, and then linking. And you don't have to go through every parameter. one of the beauties of Fusion 360 is this wonderful thing where you can right-click any box and you can edit expression. What this does is it brings up a box that you can actually do some complicated math in. Let me see if I can find one. I think the depth. Go multiple depths. Here we go. So in some of these, what are you smoking, homie? There's got to be one that has something cool. I'm gonna forget that one. I'm gonna come into 3D adaptive clearing to show you an example of what these parameters boxes can do. There we go. So you can use some math functions in here. So let's just ignore what this is doing right now. But for the sake of this expression, I want this box to be populated with the minimum of these two values, either 10 millimeters or the tool flute length, whichever one is smaller. You can edit these to make Fusion do exactly what you want really, really quick. Alex Laraway, I don't know if you guys have met him. He is, I think, the only other student besides us who's allowed to touch the VF4 or DM1. He has his Fusion configured so much that to do 90% of all of his cutting, he clicks 4 buttons per operation because he has all of these things that math out from the shape of his tools exactly what to do. We probably won't do that in ours because everybody cams a little bit differently, but it's a really powerful tool if you're ever trying to run production or you're like me and I only ever use Fusion for my own stuff on my router specifically. I can punch in all the parameters I want and it just populates for me real quick. Okay, any questions about those parameters? All right, great. We're gonna use those a little bit later when we deal with adaptive toolpaths. So that way we can do math based on the tool diameter. Okay, let's just step through this and pick our tool, then select our geometry, then do our heights, our passes, and our linking. So when I come in to select a tool, it first takes me to the tool selection window. We talked about tool libraries earlier. Default, it brings up the library for the job you're in. The tools I have here are tools that I've already put in here that I know I want to use on this part. But I can come into any of these other libraries that I have and add in random tools that I want. For now, I'm going to come in and we're going to take our 1/4 inch flat end mill. Once again, we can come in, we can edit these tools, edit anything that we need to about them, all of the geometry, all the feeds and speeds associated with them. But most importantly, the #1 thing you will end up doing is editing the tool number. So this number right here indicates the tool number that's going to be used for that. This probably isn't the greatest example. On a dumb router, like my home router or like the ShopBot, you don't need to worry about tool number. But on something like the DM1 or the VF4, or on the Shop Saber, which is going to have an automatic tool changer, you do need to worry about these tool numbers. So that way the tool calls the machine calls the right tool when its time is to go. On a dumb machine like my router, I have to manually change these tools anyway. So what number I punch in there does not matter in the slightest. But let's say for the sake of argument, we're using, why can't I edit that? Okay, there we go. Let's say for the sake of argument, we're using the Shop Saber and tool pocket number 3 is open and I'm gonna stuff this custom tool into it. So we're gonna set that as tool number 3. Okay. Select my tool. My computer lags because it's slow. Okay. Selecting that tool populates a number of things and allows Fusion to automatically calculate some stuff, which it's going to do here momentarily when my computer stops dying. it'll take those feeds and speeds that are associated with that tool and automatically stuff them into all the feeds and speeds boxes. If you're like me and you're running a machine constantly and you do the same kinds of things with it, you'll populate each of those tool definitions with the right feeds and speeds for a baseline. But as a rule of thumb, you're gonna edit them almost every time. Hallelujah. The first thing, so as we learned from our feeds and speeds class, all these numbers matter, and they're kind of out of the scope of the specific numbers are out of the scope of what we're doing. In the case that I'm going to cut out this outline, which is what we're going to do with this contour, remember my stock extended out about an inch above those, around all those walls. So what that means is my tool is going to be engaged along the whole width. It's going to look like this. So, wow, that's amazing that it nuked my head. So imagine this is your tool, your cutting tool, and it's moving in that direction, and this is the material it's cutting. That cutting tool is cutting on what we call 100% axial engagement. So what it's doing is it's slotting. The entire half circumference of this tool is cutting. What that means is I'm going to need to slow down my feeds and speeds and do a shallow step down. And you can refer to that sheet that we populated with Austin to kind of give you ballparks of what you should and shouldn't do. So I punch in whatever feeds and speeds I've got here. Interesting things for those of you who have already cammed. Turner, is Luke still floating around?
He ran out to go look at something real quick.
Okay, well, I'll come back to this then when he's here because this matters for him. But basically what it is Fusion specifies feed rates for a bunch of different scenarios. So your cutting feed rate is the primary one. That's how fast the tool moves linearly. And then you've got your lead in, lead out, ramp, and plunge feed rate. So let's say this is my stock and this is my tool. Oop. I'm gonna have to lead in to cutting this piece and then lead out when I'm done cutting. I'll show you what those look like in just a second. For now, we're not gonna worry about those. We'll get a better grip for those as we go on. Okay, so now we're gonna select a contour, the actual contour we wanna cut. So I'm gonna come in and I'm gonna select this bottom contour. So you'll notice a couple things happen automatically. It automatically selected the entire like loop here. If I come in and select like the top of this U, it'll do the same thing. Unless I hold the Alt key, I think. Yeah. If you hold the Alt key, it'll select a single. But that's not the best way to do things. If I come in and let's look at this U. If I click on that again, it brings up this box. And this allows me to select a closed contour, which is all the way around this thing, or an open contour. I'm gonna select open contour. And what that allows me to do is select other parts that are on this loop. So I select that and that, it goes, okay, I'm gonna pick everything between the two. But I'm like, wait, no, I want the top of this U. I just come in and select another piece on there and keep feeding Fusion more and more information until it figures out what I want it to do. That one is gonna be a great trick for later. When you select accept current contour, that's gonna tell this tool to come in and only cut those parts of the U, not actually go all the way around it. That gets important later on when we're not doing things that are full circle loopies. Okay. In your geometry, you also have a couple other options. I'm just going to select this bottom contour for now. Okay, so question here. Later, it's going to be important whether I selected this bottom contour or this top edge right here. I can make them both do the same thing, but remember that. And I'm going to ask you guys later why that was important, what I did. So I'm going to select the bottom one, and later you're going to tell me why it's different. There's a number of options in Fusion, and we're not going to go over all of them. You can hover over any of them, and it'll explain the best it can with a little tooltip what those things actually mean. They're really useful, and I'd suggest diving into those, but you're probably not going to learn about all of them until you start doing your own cam and running on your own machines. One I will tell you about right now is called tabs. So tabs, if you remember, basically we're cutting this piece out of a bigger piece of stock. Let's say I've screwed down the outside of that stock. If I cut this board totally loose, it's going to be able to jiggle around and bust out, which isn't good. What we can do is we can leave what's called tabs, or little pieces that will connect those two. I'm just going to jump out right now and show you what that means. Okay. If my computer doesn't crash. And it's crashing. This is wonderful. Sorry guys, today's been a lot of talking. Okay. So when I create that toolpath, it comes in and it shows me what the tool is going to do in context of my model. If you remember, my stock looks like this. My toolpath looks like that. Obviously, they crash into each other. That is also, so that blue line marks where the tip dead center of that tool goes. So you notice it's offset by some amount because of the diameter of the tool. We can use this button up here to simulate what's going to happen. So by default, Fusion does dumb parameters. If I come into simulate and I tell it to show me my stock, it'll show what my stock will actually look like. And then when I press play, it'll show me what my tool is actually going to do. So you can see my tool cutting through the material. And there's our wonderful tabs. So because I enabled tabs and I gave it some parameters, it puts these little pieces in here so that that center piece remains attached to the outer piece. That's one fixturing method that's used often in CNC routers. But we'll talk more about that later as well.
Wouldn't it be better to have it to program it to do the letters before you do that outer edge?
Oh, 100%.
Is that correct? Yeah. Okay.
Yep, that is absolutely what's useful. We're going to come back to this piece when we do adaptive toolpaths, and that's what we're going to do to cut out all these letters. Yeah, because if I stop showing my model, that's all we've made is this piece. And Benjamin brings up a great point. These tabs are really weak. They can actually break while you're cutting on accident if they're too thin. But also they make it so your workpiece has a lot more ways to bend and flex. As Benjamin suggested, that should be the last thing you do, is cut out your piece. On a router at least. Okay, so that's our tool. That's what tabs look like. I'm just gonna breeze you guys through a number of other options, because we could talk for days about 2D contours, but they're not really that interesting. And once again, that tabs was shown in my geometry right here. I'm gonna undo those. An option is rest machining, where it computes things that have been cut before and doesn't cut them again, which can be really useful. Now we're going to come to our heights. So if I go and look at the side of my piece, I can actually see, do you guys see your beautiful faces there, or do I just see that? I'm going to hide your faces. Okay. So if you look, these planes show us where each part, where each plane is, where the tool will go. So basically what these mean is different things. Top height, and you can hover over them and get your description. So the top height is the top of where this move will start cutting things. Bottom height is the bottom of where it'll stop cutting things. And then I want you guys to think about these other two. So we have a retract height and we have a clearance height. Actually, we have a feed height first. So what do you guys think the feed height does? Anyone wanting to take a stab at that? I'll pull up the tooltip. In that case, I'll just talk about it. So the feed height is where the machine will actually start moving at a rate where it expects to cut things. Obviously, we cut things slow, slower than we want to just jog around and get to everywhere. When we want to get somewhere, we go up to what's called our clearance height. You notice this clearance height is the highest of all the planes. What you have to think about with that clearance height is, okay, I have my stock that's a certain height, but I might have a screw sticking up. I might have a bolt down set that's clamping down on my part. Things like that you have to consider. Your clearance height can generally be pretty high. What happens is your tool will pull back up to your clearance height and then rapidly move over to where it needs to go. Your retract height is a similar concept, but used within operations. And then your feed height is the level at which your tool will start expecting to hit things. What these each do in Fusion is they each have a reference. So you notice the top height of our stock is referenced from the stock top, and it's offset 0 inches from the stock top. There's a number of options here, and I invite you guys to go play with those and see what they do. You can play with individual selections. So I can say, okay, I actually want my stock top to be above that point, and then I can set offsets from that. I can come in and do offsets from the bottom. All these have different uses, and they are really useful. You can also reference it from other planes. So your clearance height is 0.4 inches above your retract height by default. This is another place where it's very easy to screw up and break tools. If I don't retract far enough and I run into a screw, I've broken my tool, and now you mess up your part. One important thing, so I asked you guys earlier why it would be important that I select the bottom contour and not the top. I'm going to ask you that question now. So the bottom height is indicated as the selected contour, referring to that contour I selected under my geometry tab. Why is that selection then important that I put it at the bottom and not at the top? Anyone want to take a stab at that? What would a selected contour bottom height do had I selected this contour?
Wouldn't it just like put everything either too high or too low? And you
Exactly.
need the bottom for the reference, so you know like where your tool's gonna hit.
Exactly. Yeah, that's a really good point. So if I selected this as my selected contour, my tool is only going to go down until it would just barely touch the top of this piece. It wouldn't cut it out. But because I selected the bottom of it, my tool will go all the way to the bottom and it'll cut it out. If I had selected the bottom of this one, the tool would go down to where the bottom of that one is and cut out the profile of the one. If I'd selected the top of the one, it would go tickle the top of my stock in the shape of that one. That is a very, very important difference between Fusion 360 and Mastercam. In Mastercam, we avoid this method of selection-based heights, and we do everything based on like where we set our 0 point, so where we set our origin. we would say, okay, we want it to go minus this amount to the bottom of that stock. Fusion 360, everything is relative, and you need to be very careful with what your selections are. Hi, Jake. Great. In passes, we select a number of very important things too.
Wait,
One of the what was that?
who's Jake?
I thought I just saw Jake Nance's face pop into your video, Turner.
No, Jake Nance is gone. He's long
Oh,
gone.
oh wow.
That was Logan.
That was Logan? Wow. I thought that was
Logan's
Jake's face. Whoopsie. Okay, so the primary things you're going to select in your passes tab is you're going to select your compensation. So climb versus conventional. If you're not familiar with those terms, you'll learn them in the main shop. Fusion 360 will automatically change things so that the selected contour is cutting the right way. In Mastercam, had I just clicked this contour and said climb versus left versus right, climb versus conventional, it would set this on the inside versus outside. You see the tool is always going to be on the outside of this part because of the way I told it. Let's say I was sadistic and I wanted to put it on the inside. I can, somehow, my computer's lagging really hard right now, guys, sorry. I should be able to click that arrow and pop it onto the inside there. We'll worry about that later. But for now, just know selecting climb versus conventional will automatically offset your tool in the proper direction. And that arrow will be on the side of the contour that the center of your tool will be. If that arrow was inside the part, you know it would mar what we were trying to do here, and it would not actually follow this outside contour. Does that make sense? Is there anyone who's confused about that?
Yeah, I just have a super quick question. So
Yeah.
I've watched the video on the climb and conventional milling. And so is it generally better to conventional mill and then like a finish pass climb mill? Or does it not really matter that much?
That is a fantastic question. The answer is much more complicated than I'm sure you're hoping. Basically, it depends on your machine, it depends on your material, and it depends on what you're trying to do, and your tool as well. As a rule of thumb, in metal, on the machines that we have in the shop, we'll pretty much always climb mill. There's no reason that we should ever need to conventional mill. But
Gotcha.
as soon as you hop onto a CNC router, and you start working with woods and you start working with machines that have what's called backlash, it matters. And you'll more often use conventional on a router than you will climb. Because you're often dealing with things like plastics or woods, which benefit better from conventional.
Okay, perfect. Thank you.
Yeah, it's a weird thing. So ask more about that. Every time you came apart, ask someone who knows, would this be better climb or conventional? And you'll start to figure it out.
Okay, sweet.
Thank you for that question. Okay, on here too, we can also set roughing passes. So we can say, instead of just trying to do this in one shot, start from the outside, mill a little bit down, and then move in, mill more, move in, mill more, move in, mill more. Multiple depths allows us to say, don't go all the way down on your first one. Go a little bit down, cut, a little bit down, cut, a little bit down, and cut. Stock to leave allows us to leave stock on the outside of a contour. So if I put, zero that out. If I say leave 1/2 inch of stock on the outside, you'll see my toolpath will update. Oh my. And all of a sudden, instead of my toolpath running along this line, it's running along this line. It's leaving 1/2 inch of material on the outside of that contour. That is useful, but it can also mess you up. But just know you will use that in some situations. I'm just gonna speed through this. Sorry guys, I've been moving real slow, haven't I? You can do it axially as well. So in line with the tooltip. So instead of cutting all the way down to something, you're cutting a little bit off of it. Smoothing is a parameter that I will just tell you guys to just check every time you use Fusion. It doesn't automatically select, but you should click it. What it does is instead of doing a bunch of straight lines and trying to approximate an arc like a 3D printer does, smoothing will actually use arc commands and actually send the tool in a defined arc and shorten your G-code a lot. Feed optimization, we're not going to worry about.
Well, on that, Tyler,
Yeah.
Both of the Haas machines accept arc commands. Do we know if the Shop Saber will accept them?
It should.
It should.
Yeah, its machine definition will tell us that. And if it doesn't, then it will just reject arc commands. Fusion will let us know and it'll be like, hey, I'm converting all your arc commands into straight lines because your machine doesn't take them. So we can set that. All right, I'm going to go over linking real quick. Actually, my computer's going to die real quick. So linking controls our lead in and lead out. So if we come in and look at this toolpath, my computer loads and doesn't die. You see the tool comes down along this red line and then sweeps, actually no, it comes down along the yellow line and sweeps into this and then moves along that blue contour. That's called a lead in. Fusion 360 does lead ins and lead outs really weird. Mastercam, everything makes a lot more sense. Fusion 360 is confusing. It does all lead ins as arcs, not as straight lines. So you have to think really hard about these numbers. So you're going to specify a lead-in radius, a sweep angle, and a lead-in distance. I want you guys to play around with those and see what you can do with them. You can also lead in perpendicular, where it will not do an arc. You can also select whether you want to even do them. Sometimes you won't. For those of you who are familiar with ramped contours, this is where you do that in Fusion 360. So if you want to do a ramp, so instead of plunging down in and then following a contour, you can slowly plunge as you go. It's a very good machining strategy for getting a really good surface finish, as well as making sure constant tool engagement and you're never plunging.
And that's one instance in some cases where you would want to disable lead in and lead out, right? Because if you're doing ramped contour and you're ramping into a flat object where you have material both inside and outside your contour after you're done with the cut, then if you do any sort of lead in or lead out, it's going to just plow into that material in a not so gentle fashion. So that's one instance where you would generally want to disable lead in and lead out.
Correct. Okay, guys, that's all we're going to cover for today because my computer's about to die. But what I want you guys to take away from this is there's a lot of options and look at the tooltips. I've highlighted the ones that you guys will touch most often right now. But sometimes there'll be times where you're going to touch something you're not familiar with. Google is a great resource, and Fusion 360 is a really common CAM package. So there's a lot of documentation. Make sure to read it and get familiar with what you're doing. I've known people who CAM with guess and check, and that's a really, really bad idea. Like, do not guess and check. Know what you're doing before you do it, or you can get really hurt. Okay, so we're going to wrap up now. I'm going to give you guys a couple post assignments. One of them is going to be to come into your data panel, go to your home, come down into, so scroll all the way down, and you're going to come into these samples. In the CAM samples folder, there are a couple ones that I'm going to refer you to that you're going to play around with. And then I'm going to send you guys a part that I want you guys to put some contours on, and I want you to see what happens. And I want you to try to learn. I'm going to tell you to do some things that are a little frustrating. And if you can't figure them out, great. We'll talk about them next time. But otherwise, try Google searching. I will tell you in Fusion 360, one of your biggest issues is going to be Fusion doesn't give as many checkboxes as it does graphical things to click. Clicking on arrows reverses them. Clicking on a contour again while holding down a certain key will do different things. You're going to have to learn those and be proficient in them to make Fusion do your bidding. Okay, guys, that is a good overview of 2D contours. I will see you guys next time. And I'm going to be sending out another when is good. We're going to try to find a different time than Thursdays at 1 because school has started and things may be changing for other people. So I know several people aren't here today because their schedules have changed. I'm going to go through and send out that when is good. Any questions before my computer decides to die? All right, guys. Sorry that was a lot of blabbering today. I promise in the future it's going to get better. Thanks, guys.
You're great.